Good morning. Or whatever it is, wherever you are. It's a better LGA, though. So one of the things I kind of want to address is our initial setup time. I've thought of possibly saving the model, although another way to do that, at least to get that result, might be if I do a temperature reduction thing, which it's been a long time. Gradient descent. Compute cost. Is that alpha? Seems like that's alpha, which I am not. Well, or a different alpha. That's alpha color. Yes, we're not doing anything with that right now. Sample predictions, evaluate predictions, incremental update is the main one. What are we keeping in here? Oh, that's our cost history. Well, there's a step. This is a system I built to estimate scores for Stepmania for songs I have not played. So in here, white is an actual score, blue is the estimated score, and there actually are a couple of unplayed step sets down here. And then red is a fudged up overlay of the notes per second to kind of fit within the same schedule, same system. And let's see here, where's the reload? So I do this like bootstrap process. To try and get the initial model, which takes a while. So I wonder if I can do a sort of a temperature thing where you start off moving faster and then kind of decrease that over time as you get registered in to get that to converge faster. However, in order to maintain this interactive display, Stepmania is a open source DDR and other rhythm games. Yeah, I think that's like autoplay mode. And this is a song I will never play because it's an 11. The start isn't too bad, but it's probably going to pick up pretty soon here. I mean, even this isn't too bad, but it sounds like the song is picking up speed in general. Yeah, this is where I'd fall over. So I'm trying to refresh myself on how all this stuff works. Oh. In order to maintain this thing's an interactively updating thing, I've written the algorithm to run a few steps and then stop so we can draw a frame, which is going to complicate things a bit. Incremental step. Set point. I wonder if that +1 is in the wrong place. It pretty much seems to work. So that's just the graphing step. This is Lua. Oh, so this is only used for the graphing side of things, it looks like. incremental update. Well, we do have the size of our history. Tells us how long we've been going. Cost history less than maximum iteration. Certain tick size, maximum number of iterations per round. So, if we were to try something larger... Oh, and what I need to test the convergence is I need a way to reset this. Is it you? Okay, so the initial value of that is u. Don't seem to have any leftover code from it. Oh. Okay, we apparently have to do some more initialization there. I wonder if stage, seed, offset, scale, manual songs. Nothing else in the global data else seems to be dependent on that. Am I forgetting about something else that does some setup here? To a large extent, yeah. Oh, I haven't saved it yet. I mean, I did go to computer science in college. It was Bachelor of Arts, so it wasn't a huge part of it. But yeah, it was it was like basic listings in magazines back in the day. And figuring out other things from there. Data debug. Return table. So that's probably just a printout. Hey, Noctis. How's it going? Ah, okay. So we've got an initial theta. Chemical, ooh. Okay. And that should update it. Why was this doing weird stuff? Oh, maybe that factor was too large. Maybe that's not it. And maybe there's not much room to, to increase it in that case. Oh. Yeah, so we're really close to blowing up. Wow, okay. Hmm. Yeah. So we're kind of going as fast as we can right now. Okay, that definitely started out with a larger error. The initial state is not so great. And I don't know if that got us to this point all that much faster. What seems to be the contributor here? Okay, we start with a really bad C. All that stuff going that way. Which means that our values, everything just kind of at 0 are just kind of systematically wrong. Or biased in a... Well, yeah, most of the large factors end up being negative. So that probably gives everything sort of a negative tilt. But then a lot of them are inappropriate. Well, alright, we can't do a whole lot with temperature then. Because we're already kind of pushing the limit there. Well, if I could start out there, and then once we get a little bit locked in. Oop, I just need to exit that. I don't currently have an iteration count, though. It's allergy season. So what do I have? Is that current cost? Average cost? Average cost. Set label. Oh, I have a general feature for graph label. Get child label. Background data label. Well, now that had Graph. Cost. Well, it's going to be near cost. But it's still going to be like, well, like it's going to be a label. It's bitmap text. X-axis label. I forget what the coordinate system is like here. Well, that'll be sort of visible. Well, Stepmania has a very peculiar graphics system. I guess you would call it a retained mode graphics system. Well, all of this stuff was originally set up to do like, we'll do this little, we'll do like the life bar, and we'll do this little overlay as parts of the screen. So they were originally thinking, okay, we define a basic layout of some graphics, and maybe there's some simple behavior. I think that some of this derives from, it was an XML format, which is, more data-based. So they've got this, like, tree of graphics as the main way to get stuff on screen. And then you kind of have to reach into that graph, that tree of graphics, and update things to move stuff around. So it's a little awkward to work on. Actually, I guess to a certain extent, it's a little like web programming. You've got a document object model and JavaScript manipulating it. Actually, I probably don't need to string format this. It's incremental history. I just want the count. So Lua, it's just array name pound is the size of the array. Attempt to index a nil value. So does it have to be like immediate child or something? How are we updating? Okay, so you were directly capturing yourself. Okay. Let's be picking up a little bit. All right, so it takes us, I don't know, 800 iterations to get there-ish. No, what I was looking for was... That was like 1.5. Yeah, it's still similar to converge to that level. I guess what we're really looking at was what is our instability period at higher counts here? So it's like 300 iterations. I need to take a short break though. I'll be back in a bit to see if we can figure something out there.
Uh-oh. The compass is gone.
Hmm. Technical difficulties in the clip display there. Alright, so we were semi-stable at 2. Which now I'm wondering, would that sort of end up in the same place? Well, it definitely starts off with a little bit of a different line there. Yeah, not quite as far. So it's like our first... first round. We definitely don't want to be too crazy. I guess I could use the error itself as a feedback. Of course, that would actually be increasing the temperature as it got smaller, which is a little weird. So what do we want? We want something that goes up and and then down. Oops. I don't know of any like super simple things that do that. What is it? It's x over. It gives you a kind of cutoff. It gives you a drop. Well, that's going to be to 0. Maybe this is a multiplication of a few things. Okay, so that doesn't restrict it enough. That's not too terribly surprising. So maybe I need something less exponential. Oh, there's also, well, large ends up being a little bit different than that. What I want is kind of a bump up and then down. I don't know if I have any of those offhand. Well, what would be, what's a normal curve? That gives you the bump. And probably there's some other kind of distribution. Probability density function. That's a whole lot of terms. Maybe I'm thinking of one of these. Is there a, other kinds of distributions? Bates distribution. And always have graphics. Multivariate normal distribution. Continuous probability distribution. Probability density function. Mean, arbitrary. I kind of need a list of them. List of probability distributions. Might be a kind of Poisson? Now, that's a given number of events. I don't know if it extends to larger numbers well. That has an extra variable. Couple extra variables. With parameter lambda greater than 0 for k 0, 1, 2. What's k? Number of samples. Number of occurrences. Expected rate of occurrence. Find only integer values of k. So out of 20, a lambda of half gives you a normal distribution. But you have to know k for this one. It might not be defined beyond it. Positive real, no expected value, and also its variance. Wait, is x even in here? Oh, k is x? So if we pick a number, huh. Well, they're certainly giving me dots here. Oh, those are the intersections. Maybe just always intersecting with this. So there might be some scaling to be done here. But that is sort of giving us a rise. Oh, but the... Right, that was middle of a 20 range. We are in... No, we're scaling to, interestingly enough, about 0.2. Well, no, that's 0.5, so that's like more like 0.1. No, 0.2. Interesting. And, oh, it has its peak around 4. So if we want to say our peak is around 100, that wasn't quite what we wanted. Oh, that's... Alright, this is a probability distribution function. If you spread it out, you have a much lower you're spreading stuff out. So I might have to do... Oop, that might be too much. Oh, is that around 4? So if that was what, like 0.04? 0.04. Actually, we think we might want to get more than that. Okay, so problem. X factorial is going to be a expensive thing to calculate as we go on. I need a simpler function. Oh, with finite support. Huh. Conway-Maxwell-Poisson. You see, there's no graphs. So I don't really know what I'm getting. Contiguous distributions? Two parameter with one mode. Now you're only 0 to 1. Now we've got multi-levels of definition here. Oh, and there's another factorial. Maybe I just have to do a hard conditional switch. I don't know, is there anything like a... Wrong kind of curves. cubic plane curves? Yeah. That's more of a cryptographic thing. What would you call that? Would you call this like a one variable function graph? It's a bunch of individual things. It's probably out there, I just don't know the right search terms for it. Because those, well, I guess the 0 to 1 functions are a useful subset. I technically want an infinite one. What are you? You've got kind of maybe the bump we want? Then how do we flatten out infinite zone? My original thought was multiply by something tending towards 0, but it needs to be tending towards 0 on both sides. The function we want to get out is the function we need to multiply by. Over that space, you're there. Okay. So I think that one is asymptotic to 1. Is that this number? No, that's always to 1. It just affects the degree of the curve. We do want to start out small. Ooh, that actually starts out... If we run at 0, that would be not good. And even the 1 is possibly 0 itself. Wait, where? You're not asymptotic to 1. You're going and going and going. No, I'm look at the log. Okay, yeah, 0, small amount. Small values, very, very small values. And what is our... What is this number? That is where we hit 0.5, actually. So if I divide that down... And I don't actually know that I need to, like, decrease temperature after that. What I really want to do is increase things a little bit in the early stages. Does it end? 4's end. Man, it's an orange day. Okay. Got a little bit out of control there. That's apparently too much. Very, very odd striping effect. Makes me think that it's not full iterations. It's the number of times it was called. So some of those are clearly way the heck too huge. Or too small? Maybe it's more of an maybe it's more of an overshoot problem with large numbers. Because that would have cut off as soon as it got to 100. Yeah, so the early stages, we just have to use a constant. Whoa, okay. And then, as we approach the 0.5, it's still able to blow up. It is just literally that, which can go... The number we put in is the 0.5 point, and 0.5 seems to be way too much. Yeah, I don't know that we're actually... And then we hit we blew up and then hit 500. Which did not actually do any better. So I don't... It seems that going any faster is going to be unsafe. So it's interesting that this is still stable but slow. Could I use... Okay, so we do that every time we hit 0. And that's the first one. And we do that every single iteration? This is the number of iterations of everything we do. So actually, we're only calculating this on entry. So we know what the values are. We don't have a good feel for how different they are. Oh, report script error. Oh, what was it? So we have the cost. We're printing out the most recent one. I'm looking at is the difference. It's going to be extremely spammy. Oh, no, actually, just the two numbers doesn't actually help me much. I need to do the math. Oh my gosh, that is so many decimal points. E to the -7. Now we almost want something that's like, you know, inverse of that could be kind of dangerous. But for very, very small numbers, as the numbers get smaller, that's going to be let me see. I don't necessarily want to blow up like that. Oh, here's one I forgot about. Oh no, that's exactly the same. Do a slight increase in our advancement as the that could have some weird feedback cycle, couldn't it? Better we get the at least if it started blowing up, it would back off. So the smaller that gets, but this is an infinite thing. I want something that gets larger, but not infinitely larger, as we approach 0. Well, we're gonna be way down close to 0. Actually, what does it take? What do we have to invert you? Let's say kind of invert. Oops. Yeah, that suddenly looks a lot like that. But it blows up just as much. Well, that is asymptotic. We're going to be over a very, very small range. And this number we decided was where it has its crossing point for 0.5. Okay, so that's that stuff. Getting closer and closer to 1. And then we want to... Oh, that's the Y. We'd have to be offsetting the X. We want to asymptotically approach 0.02. Okay, you're -1. Oh, yeah. That's the first line, but we're really zoomed in. There's no upper limit on the error, though. So I don't know how far over to move that. I just have an absolute test on it. I mean, what if we did... Well, a simple linear thing would... I don't know if that would work, because... Like, we could take the entire range of the error, once it gets below a certain point, rescale that to be such and such. That's the cost difference. That's the total cost, which we've been reporting. Well, which is getting down to... Which is how many decimal points down? We're 3 decimal points down to be in the range we would care about. We'd almost have to be like... times 10 times 100. Uh... Where does this become a problem? It's times 10... I mean, actually, we're like 002 right away. And if it's 0.1, oh. Yep. It's wavering. Too much feedback. At this point, that would technically be less than 0.2, which would actually be slowing it down. So you just can't seem to increase. So I guess that puts us back to to speed it up, we have to save it. Which is going to be not so great if I end up making changes to the model. So maybe we need to look at that stuff first. One of the things I was curious about is if there was a particular term that had... Let's see, are we able to get that out? What are we drawing here? Where do we draw this? Right text. Oh, set text theta debug. No, I'm also drawing bars there. Set point. Perform pick. Is that model factors? Table insert. Actor frame. Set size. Set text key. So this is the theta itself. You would need to have all of the steps. I'll need to have some more water. I'll be back in a bit. Liver and a tidy
14 strength. E. Am I? I'm inside.
I don't know if Twitch is having trouble today, or if Stepmania is messing with the embedded browser. Because that would be the only thing I could think of that's like all that different. So what I want to do calculate compute cost so for theta, for all steps, we're squaring it, which is in fact, so cost-wise, that's removing sine. What I've been curious is what is the individual term? Breakdown. It's going to change what cost is. I have to remember a little bit how to work with tables. Get the predicted value. Cost equals cost. So that used to be able to initialize to 0. Oh. Oh, that's a cumulative prediction. Off of the score, overall score for the song. So how do I get each thing's contribution to the error? Prediction? The value times the factor. Oh, I'm not comparing this to the actual song values. Which, maybe that's almost easier here. Yeah, so actually... Yeah, that's exactly what this is. Well... That's for one iteration. But that's the signed error? So taking the overall error based on score. And assigning based on proportionally based on the weight in our matrix. Sort of back propagating the error. That's not what I want. I also want the prediction. This is the prediction of the score based on that. It's not going to actually be predicting the value itself. Maybe I need the back propagated error at a term by term level. So it is like this. I mean, we're taking that. Dividing the cumulative thing with a number of steps. Downgrading it. Where were we? There's set point. Model factors. But that's a frame definition. So this is like defining it. Oh, set update function. So that's the thing it automatically does. So I don't know how often that update function gets called. Do you need anything? Steps and theta. So you're just value, get child value, label value, -20. Error set text. Could maybe use some formatting there. Also, it's being proportionally placed based on the key, which is not helping in this case. You can move over a lot. Unless there's any good way to align that. I almost want to graph these. Floating GJ theta. But I've had some idea about what this is and how to scale it. Of course, these are probably like 0 to 1s, aren't they? Ish. Oh, you're math.abs and you're not math.abs, so I can't do this in one spot. Well, no, actually the multiplication doesn't matter for an abs. Okay, so those are as they were. Okay, so the scale is a little bit off. Now these are still signed errors. Which is still sort of interesting. It'd probably be even more interesting if we put it next to the value conversions. Yeah, so chaos has a really high error term. That might be getting held in place by other factors, otherwise their error terms go up. But it is shrinking over time. Alright, I think I want to switch you. But do you have any initial position? You don't have an initial position. I set this up so that 0 is right where this is, didn't I? And on the other boxes don't appear to be updating properly. Value. That's probably a better visualization of the overall error than my average cost down here. So you would think, well, just apply the error, and we're there. But using the larger alpha terms sends things crazy. So we can't do that. Actually, there's probably some feedback in like the constant term and stuff, because that seems to be hanging around 0 as we evolve. So interestingly enough, some of the things that have the largest error... Well, okay, another thing. This is... This is a signed error. Math.abs. I'm curious if you have lots of things on both sides. Which is probably going to be all scaled wrong. Yeah, that's a little bit too big. This is where you could perhaps divide by steps or something. No, well, that's already enough. So it's like both the signed and the unsigned are interesting in their own way. Interesting that constant is somehow wrong. I wonder if... I mean, constant is going to effectively be the cumulative error for the entire thing, isn't it? You kind of have to have the constant term in there just because if things don't add up otherwise, you need that little bit of offset. But it is our biggest error term. And the other thing that's interesting here is that the things with the smallest error might tell us some of the things that are most consistent, which perhaps unsurprisingly are meter and notes per second. Both of those seem to be less error in the linear term, more error in the squared term, although we're also getting bigger weight factors from there, saying it's more important to the model. Of course, those are absolute errors, that's on both sides. And we watched it enough for now. Now, in a normal session, it does kind of evolve. You get just a little bit of evolution between rounds, and it does seem to kind of pick up, chaos meter notes per second. I probably do need to scale this by steps. Just because otherwise it's going to be wildly different on a small collection versus a large collection. The signed error. I guess it could still be larger, but you should have some degree of counterbalancing there. Now, this is already by steps. And this should have some correlation to what we're doing here. Theta minus divided by number of steps. Oh, well, now it's invisible. So that puts it kind of on the scale of the other stuff, and also it feels almost too small to be useful. All right, so we have, what do we... Did I calculate this different, or am I displaying this different? I'm calculating this different. So cost probably would be an accurate representation of the absolute. Really, I need the keys here. The net could be larger. But to a certain extent, that's going to balance out. Yep, position. Which we're going to have to do some overall reallocation of space. Hmm? Oh, we didn't change error. Those take a while to get into range. I feel like I could almost invert the errors to show you where it's trending. So overall, we've got constant term. The biggest things are the biggest things in the model. It seems kind of weird that it's like certain things have large error terms. But those are not, so to speak, being turned into change in the model. Or at least they're being turned into it slowly. Now I think that the absolute error is a little bit closer to how the underlying model is attributing error to terms. So it's accumulating signed error No, where was wasn't there something that was squared that made it? Oh, that's compute cost. Which isn't actually a part of the algorithm itself, it's just a way to try and check the fit of the model. So we are applying the error proportional to the error. So the absolute total error of those terms. The absolute total error of those terms is similar to things that do not have a directional bias. So is the directional bias telling me something about my factor selection? Well, okay, so chaos is one of those things where there's a lot of songs with 0 notes in it. So it is accurate to say that chaos would not be a factor there. In those songs, but you have this like non-linear cliff. The difference between meter and meter squared makes me think that maybe it's squared isn't the right way of representing this. I mean, really, squared was just a way to try and appreciate some of the things we could. No, 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 no. Where? Mm. No, okay. No. Where do I define the factors? So probably polynomial. So it still has that initial curve to it. So that's not being defined by the fact that I chose to do squared in there. I wonder if, well, that's the shape of something, but I don't know which term it's a shape of. So we're still seeing error and influence from some of the same places. All right, so that is I mean, it is kind of a squared curve. It's just moved up a little bit. I don't know if there's any other curves that would fit that. Inverse log. So some of these are pretty good, some of these are not good, but that was the state before as well. Oh, but that if it is squared, we would almost need a square root curve to accurately represent it? Or to undo that? Would polynomial actually do that? Well, we go 2 to degree, so kinda no. Actually, is -1 square root? Or is that actually square root? Do we have a square root? Yeah. Oh, okay. So this is not root. Or was it like 1 over... No, that's something else. Actually, I'm looking at this and thinking this is totally wrong. On every iteration, we're saying if there's no C, insert a C. I don't know if I'm going to do variable degrees here. I don't know if we need to have a C. Oh no, we are building up keys. Oh no, if it's not equal to C, then we want to do this to it. Okay. Uh, whoa. Attempt to perform arithmetic on a nil value. Now we only do a root once. uh, is this the new one? Yeah, this is the new one. Pow. There is indeed a square root. Oh, that's right. It's sub-zero values, not negative values. But square roots should exist. Is there any way to stop the world and look at this? I do see some roots in there. What if I did that? Oh, you know what? I'm messing up here. We have this in multiple places. Not having an initial theta probably didn't have a big deal. Also have to define this for all the songs. Nil value, global, oh, we need to put it back right. Okay, so the prefix is a little bit hard to read. We've still got that distinctive shape to it. So the trick is the way I've set this up is that things will stack. So if I put square and root in there, we're going to get like squared root. So I have to do something to specify what my original keys were. So otherwise I can put them both in and see what got better weights. The root terms do seem to have relatively low average costs. Well, I guess the other way we do this, because I do calculate keys up front and then use that to define everything else. Unfortunately, it's going to push some of the stuff off the bottom of the screen. Okay, that made our initial... No, our error is climbing. Did this change the number of terms involved? The total amount of error we could have or something? Yeah. So this is somewhat dependent on the number of terms we have. Okay, well, chaos root actually starts with a huge error, which actually might suggest that it could eventually evolve to be a much better fit. So it's got a large signed error and a possibly not very large absolute error. Which is interesting. Okay, so chaos squared actually hit signed error 0. Fortunately, I can't see the things on the bottom because it got so big. And those tend to be some of the significant terms. Yeah, so the squared error tends to be comparable to the linear cost, sometimes larger. Root tends to be less. Alright, so chaos root is doing much better than chaos squared right now. Mine's root is doing better, or is a more significant factor, and I wish I could see the meter in beats per minute. I mean, I probably could, it's just going to be ugly as heck. You're 0, 0, 0, which means something else is allocating I times 0.5. Might not need to be all the way small. You can sort of see him. It's not completely illegible yet. So meter root is picking up a large signed error, but still a smaller value. And a smaller overall cost. Yeah, the difference between signed and unsigned is kind of fascinating because, like, I think this is larger, but that's not signed. And if you just take the absolute value total, it's much less than this. Which I guess that gets down to the volatility thing. So this is like more volatile in both directions. Constant is more volatile. I guess you could add up the positives and negatives separately and maybe it'll sort of compare them. So notes per second and net per second squared are both currently larger weights than notes per second root, but also larger errors. Well, I wonder if it's fair to consider the errors since those terms necessarily have bigger multipliers on them. Alright, so root seems better for chaos. For mines. Beats per minute. Kind of all over the place. Meter squared and notes per second squared are better models. So if we were going to pick and choose a few, we'd pick square root of chaos and then like meter squared and notes per second squared. You were just going to like hand pick a model set. Now that's, of course, that's for me. Might be different for somebody else. But I wouldn't necessarily call that like super conclusive. That like square root is better than squared. Oh, right. The roots have smaller error terms. They're going to get adjusted less. Hmm. Is it even worth having the squareds in there? We're picking up some pretty significant things for like those per second meter, so maybe. But I've not yet found terribly useful factors. And as long as I'm here, does this still work? Now, that probably will not fit on screen. This is like every combination of everything. And yeah, that alpha value seems like it might be directly related to number of factors. So, what is our... I don't have a good sense of what those numbers are. All right. So 1, 2, 3. Well, 1, 2, 3, 4, 5, 6, 7. Easier to count the twos. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 30, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62. I guess, yes, these are more. So 60 something got you 0.2. It was what? 14 of those. 15, 16, 17. So we used to do that stuff at 0.2. Well, that would be most of it. So that's, think of it around 20 to 20, 40, 60. So what does that mean? If 40 was about 0.2 and 60, we arbitrarily chose 0.1. We didn't really poke around with it. How do you get to that? Oh, 0.133. Not number steps. It should still be an accurate count. They're from arithmetic on a nil value. Arr? Well, there is a 0 there. It's the only place we use that. Now, I thought all tables were equivalent there. So then how do I get the number of keys? Well, I guess that would, if that was 0. No. We can't short circuit it. Tables as arrays. The length of an array. Maybe a table isn't an array in that sense. No, I need another break. I'll be back in a bit.
A tunnel to the center. Let
I
me
can't
get
go
down that
any
hill.
faster than this. Because
Oh.
if I do, this happens.
Yep. The trailers are actually sometimes helpful for
Why are you following me, Daddy?
Haskin is confused. Yes, Haskin is confused. Because I don't know what to do. I seriously can't.
Why are you following me, Daddy?
I don't know what to do. I seriously don't know what to do. Like not used to having this many people.
Kill me once I die.
Whoa!
No!
Okay, I saw that and it was awesome. Slowly glides down
Yes,
gravity.
listen,
Wait, that's
listen.
illegal. Okay. Oh my gosh, that should be a meme. Someone clip that me slowly falling and then put those words on it. Wait, that's illegal. Death.
Wait, what thing?
Okay, so I was speared gunned, sent flying to the air. I fall.
For the oxygen tanks, we need glass.
Yeah.
So go ahead.
Okay, well I got 2 quartz and 1 glass.
Okay, make up another. Actually, yeah, make them all, because we'll all want oxygen tanks.
You know, and I found it. There's a next to that little wreckage. There's a downed ship.
Oh, nice. There we go. So I've got wind turbines and oxygen tanks. So.
Nice.
So now there's the pairs. Insert Maxon. Turns the largest positive numerical index. Turns 3 values, an iterator function, the table, and 0. The first integer key absent in the table. So do I just have to do a loop and count? It sort of sorted itself out. Maybe were those leftover messages? Okay, so it still happened once. And it's just this. Which has its own problems. Center from Arithmetic on Annual 1679. Term error. We don't have that. Oh, maybe we do have that. No, there's the reload. And there's the message again. Because that's term error that has that. So is this a bad value of alpha? Well, this mostly works. Can't necessarily make anything out. Okay, we are a bit bouncy. But it's settling down. Or maybe we're just running slow because there's so much stuff, so many loops. Error is pretty even across the board right now because these are all like teeny tiny factors right now, which is kind of telling me that they're all garbage. We've still got that sort of x squared shape though. So maybe that's actually a factor of the scores themselves? Yeah, maybe there's a factor way down there that's interesting, but you'd have to like rewrite this to only show the x largest factors or something. Yeah, there's a burst redo category chaos. I think it's just too slow to be practical, if nothing else. So what's this error? Is that because of the particular value of alpha we choose? Oh, 0.15, that's actually smaller than what we were doing, which actually means doing that way makes it slower. I mean, maybe that lets it converge better. Okay, so we've got a rougher start. Oh, and we've still got root in here. I forget if there was a block quote. Actually, I think there was. It was like something with square brackets. I don't use it much. Okay, so we're still getting that. With this number of factors, though, it's back up to 0.22. So it's almost like it's the loop itself. It's measuring it. I get this one, yeah. Wait, is it times 5? I guess it was. That 0.22 actually leaves us scattered out more than it was. So maybe that is, it's getting a largish. A largest value. All right, so is it counting or is it? All right, 0.8, 0.9 and nothing, 0.77, 0.21, 0.74. Or maybe I have to scroll these things off before it shows them again? Because that was the point of inserting that. Maybe they were more aggressive with the deduping. Yeah. Shoot. So now I can't actually tell if those messages are happening or not. Like, need my own little report function that puts a random number in every single message. Or is there... I don't know if that cleared errors or not. Well, I guess that was continually producing them before. So that seems... We reset that to 0.2, so actually it's... the process of counting them that's causing the error? No, wrong one. 0, reset. Oh, this is the error stuff. We must not have calculated that the first time we go through there. It's actually the multiplication that causes us trouble. Okay, so it wasn't necessarily our alpha selection. When we did the 0.22, seems like we may have been seeing more stuff off the top there. I have any easy way to get this back. Oh, however, does this mean we can just do that? Inf. Well, no. Although, this is something we could determine once. Well, that's initial theta radar category. We have plus equals. I see no evidence of it. So unfortunately, none of our experiments there really panned out. I probably need to do more, like thorough experiment design. I was pretty much going by feel. I wasn't like saying, well, after X number of iterations, our cost is less than such. Or there's the whole training and test data sets. So the way to speed this up would then be to save theta, which is a whole other animal. Made any progress here? We've got the root factors. Oops. Oh, need to take out the reset. That was for testing. Got a cost display, which is still going to be inscrutable to anybody else. saving. might be a thing. Load config. Save Lua table. Config system. Is there like a self-load, load, file check, load config Lua, I guess is the other side of that, which I don't know if that's going to be appropriate to our purposes or not. I mean, it's going to be a pretty simple table. We also have to consider file name, calculations. Well, this seems like some sort of object setup. Let's maybe figuring that out. Yeah, there's a lot to profile dir. So that's going to be a whole thing. So it's like I want some stuff like that, but I don't know if I want a thing exactly like this. I guess I do want a per player data set. That actually gets saved. No. Local profiles? Or does that get saved? Recently updated stats. Not gonna be that. Not gonna be that. Ah. Alright. No, yeah, that's today. So that's not... Okay, so we have to investigate that then. Because that is not per profile. That's all going to be file save stuff. Alright, so that will be the things to work on next time. See if we can save factors so we skip that whole training step. Or at least start off in a better place and just tune it a little bit. And we also have to figure out why we're not saving our settings in the profile anymore. Did we used to do that? Actually, it wouldn't be here. I forget where it was. Nobody likes local low. Okay, I've really forgotten where it was. Look, I know I copied that stuff from somewhere. Oh, I might have never run the other one on this computer. I'm not sure which one. No. Machine profile. And those, okay, so, local profiles. Okay, yeah, so that may have never worked. So it's got that. But there's no indication of a method in this that would identify as it being per player. Well, I never necessarily set it up to be multiplayer, but still saving the profile would be nice. Alright, so I guess that's a battle for next time. Surely there's a way to get that profile directory. But for now, it's going to be on to lunch and stuff. Thanks to everybody who hosted me. Let's see if we have any other coding going on. This is what I'm usually on. Not a whole lot. Well, other thing I've been doing lately is Satisfactory, which can be a little bit like programming at times. Look for some place cool to hang out. EmeraldBot is playing some Satisfactory. Yeah. Thanks for hanging out with me. Goodbye, and until next time.